feet and get in here, all right? Yeah, Mama Schwa's getting mad. All right, I'm recording now, and I'm going to go jump into, I'm going to share my screen with you kids, so if you want to get yourselves ready, we can. If you just want to sit back and watch, that's fine, because you can always go back and look at this, because as you know, I always record and then post this. And I know some of you really do enjoy and take advantage of the fact that we do that. So, all right. So let's say right here, if I'm looking at a function like this, this is a parabola, yay or nay?
Yay.
Yay, it is. Does it have an inverse right now? No, it does not, because it will not pass what test?
Vertical line test.
Oh, it will pass the vertical line test, because if you want to pass the vertical line test, that's what you wanted. That's the test for what? Your vertical line test is a test for determining if something is a
function.
Function, very good. This is definitely a function, because if, remember, vertical line test, because you know you'll have something like any kind of parabola, it's always going to pass the vertical line test. It's going to hit once. But in order to have an inverse, it has to pass the horizontal line test, right? So to have an inverse, you have to pass the H. Can I put HLT there for horizontal line test, friends? Good. Okay. So right here, if we want to, we know that we have ourselves a parabola, right? So if we want to restrict the domain, where should we restrict the domain? At its
Vertex.
At its vertex. Good. So right now we're in standard form. Do you friends know or remember how to find the how to find the vertex? If you're in standard form, do you remember?
Isn't it like b divided by 2 squared and then to that?
Oh, that's the quadratic formula. You're getting crazy. That's how you find the zeros. How would you find the vertex? I heard somebody scream something out. Let's go for it.
Do you complete the square?
You don't have, well, you could, but there's actually a quicker way to do this, just to get the vertex right then and there.
You factor it?
No, you don't even have to. If you're in the form, like if you have y equals ax squared plus bx plus c, to get the vertex,
b over 2a.
X equals negative b over 2a. Very good. The x coordinate, do you remember if you're in standard form? Right, this is standard form, so if you wanted to find your vertex, you just do the opposite of b over 2a, and in this case, we have b is negative 8, so it's going to be the opposite of negative 8 over 2 times 2, because it's the opposite of b over 2a, because this is, here, I'll even change my colors, look at me go. So this is, I'm supposed to change my color. So this is a, this is b, and then this is c right here. So we have that. So in that way, we're going to substitute that in. So if I asked you guys, what is the x coordinate of my vertex?
Mm-hmm.
2. Thank you. Okay. To find the y coordinate, all we have to do is substitute in 2 into the function. So why don't you guys go ahead and do that? All right. Why don't you guys go ahead and do that, and then tell me what the y coordinate's going to be. Can somebody do me a favor? Hi, Jace. Can somebody reach out to Shreyas for me? Shreyas is not here, so can somebody reach out to him? So I'm trying to figure out who's here and who's not here. Did D'Onofrio get here yet?
Yeah, I'm here.
It's good to hear you, boys. Okay. All right, so we want to find f of 2, because that's going to be the corresponding y coordinate for our vertex. When somebody's got it, that would be great. Anyone? Anyone? This thing on? Anybody
Yep,
get negative
3.
5? Negative 5? Is it negative 5?
I got 3.
You got 3.
I got 3 too.
All right, then I screwed up. Okay, so then it's going to be 2 times 2 squared minus 8 times 2 plus 11. So that's 4, 8. 8 minus 16 plus 11. Oh, it is 3. Yeah, I don't know how to add. Okay. All right. So it is 3. So our vertex is at 2, 3, which means true or false, will there be zeros? Will this function have zeros?
No.
No, it won't have real zeros, right? Because it's going to be where?
Above the
Above that,
x-axis.
yeah. So now here's the thing. If you wanted to get a quick sketch, right? We know that we're at the point over here at 2, 3. Every time I try to change the color, it won't let me. Okay. So I'm over here at the point 2, 3, right? What's my y-intercept?
11.
Good, 0, 11. So the nice thing that we could do to get a quick picture of this, we have 0, 11. And what is the point symmetric to it?
5,
Did somebody say 5? You sure?
no, 4.
It should be 4. Good. It's 4, 11 because remember you're 2 units away for it's along the x's. You look at your x's, so that means this is going to be 4, 11. So we know then that this is what this function is going to look like. So we got a quick sketch of it by A, finding the vertex, and then blah 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 blah. So now, right now, in its regular form at this particular stage of the game, this does not pass the horizontal line test, but we restrict the domain to do where? So we restrict the domain. Which side would you like? What side of the parabola would you guys like? So we're going to restrict the domain. I don't care what side you pick. Remember, it doesn't matter what side you pick. You want to pick the
Right side.
right side. Fair enough. Okay. So we have f of x is equal to 2x squared minus 8x plus 11, but we're restricting the domain to be x is greater than or equal to 2. Okay. So we've done our domain restriction. Now the thing is we want to find the, let's say we want to find his inverse. Okay. So we want to find out what his inverse is. So I'm going to have to go to a new page. So we had our f of x, f of x was equal to 2x squared minus 8x plus 11, right? And we restricted, we know that our vertex is at 2, 3, and we restricted the domain to be x is greater than or equal to 2. So here's my thing. If I asked you guys, how do we get this into vertex form? What would be one way that we could put this into vertex form? Wow, we got to go back and think about that. Oh my goodness.
Why do you complete the square?
You could complete the square. What's another option?
Quadratic formula.
What's the purpose of using the quadratic formula?
To find the zeros.
Mm-hmm. Is finding the zeros going to help us?
Okay.
Hmm? Well,
No.
let's think about the 3 different forms of a quadratic function. We have standard form, which is right in front of us. We have standard, right? That's one form, which is that right above. What's another
Factored.
form? Factored form, okay. And what's the third form? There are 24 people in this class right now. You're going to tell me, not one of you can tell me what the third one is?
Vertex form?
Vertex form, thank you. All right, so it's going to be vertex form. Now, why would we like to use vertex form?
Because then you can
Because we restricted the domain at the
vertex.
vertex, good. All right, so if we want to do that, so in other words, if we want to do vertex form, if you remember, it's y is equal to a times x minus h squared plus k. Do you all remember that? Does that look familiar to all of you? Yes? Am I going to have all right. So if one of you wants to have a conversation with me, everybody else can sit back and watch. We know that h and k are going to be 2 and 3 respectively. So we have y is equal to a times x minus 2 squared plus 3. How am I going to get a? How would I get a?
Just plug in x.
You have to plug in x and y. Where would I get those from? Hint, hint.
The y-intercept.
The vertex.
We can use the y-intercept. We can't, if we use the vertex, everything is going to cancel. We can't use it twice because the vertex is already in the function, so we can't use that. But whoever said, let's use the y-intercept, right? If we use the y-intercept, which is 0, 11, we can just plug in 11 is equal to a times 0 minus 2 squared plus 3. So now we have 11 is equal to, that's negative 2 squared is 4a plus 3. Subtract 3 from both sides and you get 8 equals 4a. So what does a equal? Look at that magically. Okay, so now the vertex form, of this function is 2 times x minus 2 squared plus 3. So this function right here is the same thing as this function. It's just that it's in a different form, right? And remember, our goal was to find out what the inverse is because we restricted the domain. So we're only interested in this part of the graph right here. So this guy in yellow, it's the right half of the parabola that was decided on, and we want to find out what his inverse was. So the only way, or one of the ways for us to find out what his inverse is first of all, we have to put it into vertex form. So then that way we could go ahead and find the inverse of this function. And how do we find the inverse? First thing we got to do,
Switch the y and the x.
switch x and y. Very good. So we're going to switch x and y, and then we're going to solve for y. All right, so the first step in this process is we are going to, solving for y, first thing we're going to subtract 3 and then divide by 2. Good, so x minus 3 divided by 2 is equal to y minus 2 squared, right? Because I subtracted 3 and then divided this 2 out. You always want to make sure this thing is by itself. Now, what's the next thing that we have to do to undo the squared? We take the
square
root, which means, and that means there's going to be how many solutions?
2.
There are 2 solutions. And then we get y minus 2 over here, right? So, because it's the square root of this squared. So now I need some space, so I'm just going to erase while you guys are copying, because I know some of us are furiously copying, trying to keep up with me, because I just move so fast. So now, do you see how there's 2 different solutions there? My friends, do you all see that how there are 2 different solutions?
Yeah.
Good. We have to pick one of them because we can't have both of them. There's 2 different functions here. Which function do we want?
The positive one.
The positive half. Good. Because we picked the positive half of the parabola, so now we have to pick, I'm just going to go over here anyway, and we know that we have plus or minus the square root of x minus 3 over 2 is equal to y minus 2, but I have to add 2 to both sides, so I have plus or minus y minus 3 over 2 plus 2 is equal to y. But as somebody said, we want the positive half. So therefore, f inverse, I don't know why it doesn't want to, there we go. That f inverse of x is going to be equal to the square root, this should be an x here, shouldn't it? X minus 3 over 2 plus 2 is going to be equal to his inverse, okay? Now I'm going to show you that. We're going to go over to my favorite. Guess where we're going to?
Desmos.
You know we are. Of course we are. So let's go to my desktop, hit share, and close this out. And then we're going to go over here. Can you guys see? Do you see that I'm going to Desmos? Can you all see that?
Yeah.
Good. Okay. So we're going to go into the Desi of the Desmos. And we're going to put in f of x is equal to 2x squared minus 8x plus 11. And you'll see there's that parabola. But again, if you remember, we're going to do x is, where's my thing here, is going to be greater than or equal to 2. So now we have that half of the parabola, right? So then if I wanted to go ahead and do his inverse, I'm just going to call his inverse g of x is equal to the square root of x minus 3 divided by 2. Whoops, x minus 3 divided by 2, and then plus 2. And if I draw the line y equals x, you will see that it actually does go literally over that side of that parabola. You all see that? Hello? Hello?
Yep.
Okay. Now, if we went the other way and we switched this around, we would have that half of the parabola, and then you would have that negative square root function that would take care of the other side of that. Okay, so for you guys, remember, when your function is even, or you have an even degree function, you're always going to have to restrict the domain. Would I have to restrict the domain on a cubic function? Would I have to restrict the domain? So for example, if I go over here to this, and I go to a new page, would I have to restrict the domain for something like y equals x cubed plus 4? Would I have to restrict the domain for something like that?
No,
No. Why?
because it follows the 1-to-1 ratio.
Yes.
Rule, so that for every x value, there's an individual y value.
Yes, that's beautiful. This is already one-to-one, so it does not require any domain restrictions. And again, when you are odd, for the most part, sometimes, you know, if we have something like this, we definitely have to restrict the domain. Does everybody agree with that? Because again, you're not passing the horizontal line test, so you have to go ahead and restrict it somewhere. But if you have something where you have a cubic function in its purest form before we grab this part and stretch it, it's gonna cause problems for us, okay? So those are good things to keep in mind. And then the last thing I'm gonna do is I'm gonna show you guys, we're gonna work on a problem like this because I know this was on the bonus. You were asked to find an inverse of this and then actually show that they were inverses of each other, okay? So since I only have like 10 minutes left, I'm gonna be buzzing through this, okay? So the first things first is I am gonna go on the hunt for the inverse. So I'm gonna find the inverse first and I'm gonna switch my X's and my Y's. If you're okay with that, everybody say, okay.
Okay.
Great.
Okay.
And now I'm going to throw this over 1 and we're going to cross multiply. So I'm seeing a 6xy plus 7x is equal to 4 minus 5y, right? Because if I multiply this times this, I'm going to distribute the x through. And then the next thing is you want to get everything with a y to one side and everything that doesn't have a y to the other side. So I'm going to move the 5y to the left and I'm going to move the 7x to the right. So then this is going to be 6xy plus 5y is equal to 4 minus 7x. Because if you remember, anytime you move something to the other side, it changes signs. So now beautifully here, I can factor out a y, which is going to leave me with 6x plus 5 is equal to 4 minus 7x. And now I can say that my inverse function is going to be equal to 4 minus 7x divided by 6x plus 5. Okay.
Yeah.
Okay. So going back to this guy right over here, going back to G, can you guys tell me what my domain restriction is for G? It's where this is going to equal 0, right? That's where your domain is going to be. So X cannot equal what?
-7/6.
Thank you. X can equal -7/6. And then the range, if you watched my videos, I would tell you, you would compare the degree downstairs with the degree upstairs. The 4 and the 7 are negligible. So this ratio simplifies to what? What does this simplify to?
Just 5/6.
Y can equal, say, -5/6, okay? So now when we go over here and we look at the domain and range for the inverse, what is the restriction on the domain for my inverse? What can X equal? If we set this equal to 0, what can X equal?
-5/6.
-5/6. Isn't that interesting? Because remember, the domain and range flip-flop. So if you wanted to tell me what the range was without even looking, I'm sorry, this is Y. If you wanted to tell me what the range was, Y can equal what here? -7/6, because remember, your domain and range is always do a flippity-flop, okay? So now what we're going to do is we're actually going to algebraically prove that they are inverses of each other. And we're going to do it by showing that, you know, G of G inverse of X equals X. And then you guys, when you hang up with me, are going to prove that the other way is also going to spew out an X, okay? You guys are doing this part, I'm going to do this part, okay? So I'm gonna go to a new one. And since we're gonna do, I wanna show that G of G inverse of X equals X. That means everywhere I see is a G, so G of X is equal to, I'm just gonna rewrite it, is 4 minus 5X. Thank you for hanging in there, kids, we're almost done. And then 6X plus 7. And then the inverse is equal to 4 minus 7x over 6x plus 5. Okay, so now that we have that, we're going to go ahead and everywhere I see an x up here in G of X, all of these x's are getting replaced with this monster down here, okay? So I'm going to go ahead and do that. So that means then that G of the G inverse, I'm plugging in 4 minus 7x over 6x plus 5 everywhere I see an x in G. So it's going to go in here, and it's also going to go in here. So it's going to be 4 minus 5 times 4 minus 7x over 6x plus 5 divided by 6 times 4 minus 7x over 6x plus 5. And then that's a plus 7. Yeah, and then there's a plus 7. So I want you guys to look at the numerator as its own entity and the denominator as its own entity. And we're just going to kind of take things from there. We got some multiplying to do. We got some common denominators to find. So there's a lot of algebra that we're going to do, but it's going to work out sweetly if we do the algebra correctly, because we already know that these two are inverses of each other. So this should all simplify to what? This should all simplify to?
X.
Yeah, and it's going to be sexy. All right. So let's start with this. We're going to start with the numerator. So we have 4 minus. Now, when I multiply the 5 through, I'm only multiplying the numerator. I'm not multiplying the denominator because technically this is 5 over 1. So I'm distributing the 5 this way, but I'm not doing anything over here. It's like, 1 times that down below. So this is going to be minus 20 plus 35x divided by 6x plus 5. Okay, so I distributed the negative 5 just to the top, not to the bottom, because that's algebraically the proper way to do it. And now we're going to take a look at the denominator. And the same thing happens down here. This is like a 6 over 1. So the 6 is only getting multiplied by the numerator. It's not getting multiplied by the denominator. So we have 6 times 4. So we have 24 minus 42x divided by 6x plus 5 plus 7. So now I'm going to come on up over here. And when I look at this, I have to get myself a common denominator in the numerator. And then I have to go look at my denominator and then find a common denominator there. Because remember, you're treating this separate from this for now. And this is like a 4 over 1, and this is like a 7 over 1. So when I look at my numerator, the common denominator is 6x plus 5, because that's a 1, and that's a 6x plus 5. So that's going to be 4 times 6x plus 5 over 6x plus 5. And then, excuse me, minus 20 plus 35x over 6x plus 5. That's my numerator. Then going to my denominator, again, I have my 24 minus 42x over 6x plus 5. And then this is going to be plus 7 times 6x plus 5, over 6x plus 5. So now I'm going to distribute this 4 through. So that's going to give me 24x plus 20 over 6x plus 5. And then minus 20 plus 35x over 6x plus 5. Hold on. My pen is getting a little wacky. So hang in there, Mr. Pen. Thank you. Plus 5. And that's going to be all over. This is nasty. I know it's a lot of, but it's delicious algebra. And when you're going to watch things disappear and simplify in no time. So just bear with me here. I'm just not skipping steps on you guys so that way you can see it all come to life because I care about you. So I'm going to distribute the 7 here. So that's 42x plus 35. And that's all over 6x plus 5. So now let's look at the numerator again. When you have the same denominators, you can add your numerators together. So what I want you guys to see is that if I add my numerators together, right, the two 20s cancel and I have 24x and 35x, which looks like it's going to give me 59x. Is everybody okay with that? Good. I'm going to talk to myself. So that's 59x. I'd rather you just watch and then go look at this later on. Okay. So that's what the top becomes. And then my numerator is 59x over 6x plus 5. And then let's take a look at this guy down here. And if you notice, your 42x's are going to cancel out, and you are left with a 59 divided by 6x plus 5. So the magic is happening now. So if you look at this, and I'm going to change the color to orange. So we have 59x over 6x plus 5 over 59 divided by 6x plus 5. So if we multiply the top and the bottom by the reciprocal of 6x plus 5 over 59, and then times 6x plus 5 over 59, because again, this is all 1. Everything down here cancels out to 1. And then if I look at my numerator, the 6x plus 5's cancel. I'm left with 59x over 59, which is, dun, 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 it's x. Ha! Your job is to go the other way. So you're going to show that g inverse of g of x is going to equal x, because I just showed you guys this way. So that's going to be nice practice for you guys to do, and it's going to help you actually answer the bonus question. All right. And then for those of you who are like trying to catch up and all that, you can go ahead and, you know, figure out what it is that you need to do. But yeah, but I'm super proud. And I will have this up as soon as it's ready to go. Yeah, honey.
For the problem that you did, like, before, not this one, the one before that.
Yeah.
On the assessment, it says like to complete the square. Can we do it the way you did it, or do it?
Yes. When I remember, like, I realized that when I said that to you guys, that that was one way to do it, but it's not the only way to do it. So you don't have to take my hint. I think this is actually a better way, the way I just showed you guys. So I think it is far better because we know how to find the vertex. We can go ahead and put it in vertex form, blah, 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 blah. So yes, I would go about it that way. Thank you for asking. You're awesome. Okay, wave to each other one more time. All right, wave to each other one more time, and I'm going to stop recording.